This is chapter 2-5, proving statements about segments. Please copy your codes. All right, people, this is going to take us for some brain exercise, do proof writing. You need to get your pens and paper ready. You're going to really need to put your thinking caps on. Got a lot of work to do. First things first about proofs. There are 3 rules you always need to follow when you have proofs. Always do them. It's kind of like writing word problems that you learn in 3rd, 4th, 5th grade. The teacher asks you to underline what's important or circle or highlight. Same thing with proofs. It's steps that you need to follow and you'll be just fine. That's number 1, follow the steps. Number 2, you have to commit to memory the definitions, postulates, theorems about different rules and regulations that occur in math. Once you do that, you'll be fine. All right, so here's the rules for proof writing. Number 1, you always analyze or look for what's given, for what you're asked to find, in other words. What's given. And I'm going to walk back through these proof writing steps as we go through an example. Always look for what's given. Number 2, well actually 1A. When you're given something, sometimes what's given is written in the directions. They tell you directly when they type the word problem. They give you the given when they write the word problem. Okay? Sometimes, if it's given to you in the word form, but they don't draw a picture or a diagram, then you should draw one. So if they just give you a bunch of words and you're trying to sit there and think about it, stop just only thinking about it. Draw a picture on the side. If they're saying 2 congruent segments, draw 2 congruent segments so that you can visually and pictorially see it. Okay? So make sure if it's given in words, you draw a picture if they don't give you a picture to go along with it. Sometimes when you're given information, sometimes they don't put it in words. Sometimes they just give you the information. For example, they may say 2 congruent triangles, and they may mark the triangles up. If they do that, now what you want to do is take that information and write it in word form. So sometimes they put it in word form, you should draw a picture, and then sometimes they give you the picture and you should draw it and write it in word form. Number 2, step 2. Ask yourself, what are you being asked to prove? What's true? What do you need to prove? Number 3, finally, this is a long one. This is very important. This is the most important part of this. You must ask yourself, what information must be true in order to write your proof? Okay? For example, if I say I have, and I'm going to do segments instead of a triangle. If I have 2 congruent segments, you immediately say, they say prove that segment AB is congruent to CD. You have to immediately start thinking, what information do you know about 2 segments being congruent? In other words, I say, oh, definition of congruent segments means they are the same size, shape, or length, and length, I should say, and length. So I immediately start thinking about the definition of 2 congruent segments. So again, number 3, this is the most important part. If you're asked to prove something, for example, prove that segment AB is congruent to segment CD, you immediately start thinking, okay, well, what's true? What do I need to know about segments being congruent? I start thinking immediately, okay, well, I know that they have to be the same length, they have to be the same size, same shape, and I write down everything I know about congruent segments. So you write down all the definitions in order for you to be able to prove that AB is congruent to CD. All right? So in order to prove that, here's what you need to know. You need to be able to prove that theory, so that means you got to remember definitions, you have to remember postulates, and you have to remember theorems. You have got to commit them to memory. I can't stress it enough. I know some of you like to skim your notes, try to call yourself writing down a definition. You can't just write down definitions in this class for proof writing. If you do not commit to memory definitions, postulates, and theorems and understand them, you're going to, I don't want to say you're not going to pass, but you're going to have a very difficult time. You must memorize definitions, postulates, and theorems. You must know them like without opening your notebooks or without opening your textbooks. Once you do that, you'll be good to go. So 3 steps for writing proofs. Number 1, you always write down what's given. If it's given to you in Word, draw a picture. If they give it to you in a picture, write it in words. Number 2, ask yourself, once they tell me what's given, what do I need to prove? Number 3, which is most important, well, all are important, you have got to memorize definitions, postulates, and theorems. You can't just write down segment, addition postulate one time and then be done. You have got to know what segment, addition, postulate means. What does it mean? It may mean that AB plus CD is equal to AD. You have got to know what they mean. So don't write it once. You need to memorize these. Moving forward, some theorems and other information. A true statement, again, this is a recall. You should remember a theorem is a true statement that follows a result of other true statements. Okay? All theorems, okay, Pythagorean theorem, for example, must be proved and can be proved using a 2-column proof. This is primarily what we will use. 2-column proofs, you can write it in paragraph form as well. 2-column proofs are numbered statements and reasons that show the logical order of an argument. And they look like this, for example. On the left side, you have your statements. On the right side, you have your reasons. Here's a theorem you need to memorize. Again, I say don't just write the theorem down, memorize it. The theorem is 2.1. And I'm going to say now, knowing the number is not as important as knowing the actual theorem, postulate, or definition. You can write the theorem number down. As a matter of fact, I want you to write the theorem number down, 2.1. But the thing is this. This theorem is true in any geometry book if we go to another school district or what have you. So you need to know the name of the theorem, postulate, or definition. The theorem number is not so important, but you need to know that name. Here's the first theorem you need to memorize. Segment congruence, we need to know, for one, can be reflexive, symmetric, and transitive. We did this back in 2.4. For example, if it's reflexive, that means that any segment of AB is congruent to itself, AB. Symmetric means if AB is congruent to CD, then I can switch them around and also say then, my if-then statement, then segment CD is congruent to segment AB. That's my symmetric when I switch the two around. AB, CD, and then I switch it to CD is congruent to AB. And then transitive, this is the 1 is equal to 2, 2 is equal to 3. That means that also 1 has to be equal to 3. So if segment AB is congruent to CD, and CD is congruent to EF, then that means that the first and third have to be congruent. So AB will be congruent to EF. Right? Let's make sure we understand the difference between some things. First of all, AB, number 1, let's understand AB and AB. There's a difference. One has a hat, one does not. There's a difference, make sure you know it. First of all, AB, line segment AB without a hat. And if I write AB and then I put an equal sign, for example, if I say AB is equal to CD, no hat on top of either of these. When I do not put a line and at the same time I use an equal sign, I'm going to fix this up just a little bit. So when I don't use a hat and I use an equal sign, when I put an equal in there, that means I want the number. I want the number. All right, so here we have, for example, AB is 14 units. If I write AB is equal to CD, even even though I don't see a CD, when I write AB with no line is equal to CD, that means equal and no hat. I want the number. So that means I put the number 14 is equal to 14. No hat and equal means use the number. Now if I write AB with a hat and congruent, like so here, and I say line segment AB is congruent to CD, for example. When I use the hat and at the same time use the congruent, that's very different. Now what I'm trying to tell you is this. I want you to know that they are the same shape, same size, same length. Don't put the actual number. Just know that they're the same size and same shape. Very different, but the same. Okay? Again, congruent segments that are segments that have the same length. Again, I can't stress enough. Remember, equal and congruent are not the same. When you see me use equal, it will not have a hat over the segment. Equal means use the number. I want the numerical value, 15, 3 and 8/10 or whatever. Congruent means same size, same shape. They're not the same, but they're the same. Okay? For example, my first name is Tiffany or Ms. Hackworth. Okay? Yes, I am the same person. Yes, these are essentially the same thing when I say the two up top. However, they mean a little different thing. For example, if someone calls me by my first name, I'm thinking it's one of the teachers in the building, one of my parents, family members, or what have you. If someone says Miss Hackworth, I know they want the teacher side of me. Okay? Miss Hackworth and Tiffany are the same person, however, different meaning. Here's an example of a symmetric property. We're going to write a proof for this. Here's the information that's given. Line segment PQ is congruent with XY. Look at the hats on these segments and the congruent. I'm telling you that PQ is the same size and shape as XY. I don't want the numerical value. We're going to follow those steps. Step 1 again from the rules. Analyze what's given. If it's given to me in written form, then I need to make sure I have a pictorial diagram. When I go here back to, and I'm going to go in between two screens, so hold on. When I have that, this time they give me the diagram with it, so I don't need to draw it. So number 2, prove segment XY is congruent to PQ. Right? When I do that, I set up my statements and reasons. So I think about what do I know about XY being a PQ. So you see it switched here? What do you know about that information there, about them being switched? PQ, congruent to XY. Now I'm switching. I immediately see something. I go, oh, shoot. That looks like the symmetric property. Now I'm following step 2. Step 2 is, okay, I ask myself, what do I need to prove? And then the third part is, I write down the definitions, postulate, or theorem that will prove that. So I immediately say, oh, shucks. They want me to prove that segment XY is congruent to PQ. I see their switch, and I immediately say, oh, that looks like that's the symmetric postulate. Okay? The symmetric property. Excuse me. So now I've already got in my head what I need to prove, and I'm going to use that information to prove that these two can be switched. First thing first. You almost always start with the given. You almost write given. Number 1 is the given. PQ, segment PQ is congruent to XY. Why? What reason is that? The reason is because it was given in the problem. So I write given. Number 2, what do I know? I look at this and I start thinking, oh, shucks, here's another thing I remember. Congruent segments are also equal. They're also equal. PQ is equal to XY. No hat, equal means the number. What reason is that? I have to go back to the definition of congruent segments. So the reason that these two can be written from congruent to equal is the definition of congruent segments. Congruent segments are equal, and that's the reason. Number 3. Now I switch these two around. PQ is equal to XY. Now I switch XY is equal to PQ. Why? That's that symmetric property when I can just switch them around like that. Symmetric property of equality, which was back in 2-4. And I also know I can switch it one more time. I know that when segments are equal, they are also congruent. And that's true because the definition of congruent segments. So now I prove that PQ is congruent to XY, XY is congruent to PQ by that definition.